Okay, remember this flashcard right here? That should look familiar to you. Now make sure your phones are all put away now. So, there are reasons why we need to compute an integral, and then there are methods for how to compute the integral. This problem number 7 starts out with the purple column here because they're asking us to find the average of something. So that's right here. We're finding the average. How we do that is new today. This entire packet is no calculator. It's practicing the no calculator portion of the test. They're not asking us to do a Riemann sum, so we can't do that. So we're going to learn this method. How to use the fundamental theorem and antiderivatives to find the value of an integral. So back to here. The average value of that function on that interval. So the first thing I do is write the integral that I need to compute. So because the interval is 0 to 2, I know that I will start with 1 over 2 multiplied by the integral of whatever I'm averaging. Square root means 1/2 power. When I'm taking a derivative, I prefer to leave it as a square root because the rule I have looks like this. The derivative of square root of something is equal to 1 over 2 times the square root of that something multiplied by the derivative of the something. So with a derivative, I leave the square root because the rule matches. With antiderivatives, look at your pink sheet, none of those 5 rules have a square root. But the first rule does have some, x to the n. So if I'm doing antiderivatives with a square root, I switch to the exponential notation. You don't need me to say that again. So if I'm finding a derivative, I'm just going to leave the square root because the rule matches. If I'm finding an antiderivative, I want to switch to an exponent because now the rule matches. Just a kind of a quick thing that helps. Questions? Another help is on number 4. This is a hint you'll need for the homework. On number 4, the square root is in the bottom. But same thing, because I'm going to be finding an antiderivative, I'm going to switch that to, let's show how this works real quick. Hold on a second. Make a copy here. So on number 4, here's what I would do. I would say this is equal to the integral from 0 to 1/2 of 2x over 1 multiplied by 1 over square root of 1 minus x squared. If you want to turn the page and write down this hint, that would probably be wise, like on a new page, so you have a way to get started on number 4 when you get home. So back on number 7, same idea, just I didn't have to move it from the denominator to the numerator. Question? Awesome. Okay, new idea. Okay, I'm making up a problem to illustrate a point. So raise your hand if you can tell me. You can talk to each other. What does the 8 represent? This is review from the previous unit. Talk to each other, raise your hand. What does the 8 represent? Show me your hand. Baron, what does it represent?
It's the displacement of the entity from 0 to 3.
I'm going to say it back to you just slightly different. The v of t would be the velocity of some moving object, and 8 would represent the fact that at time 0, the object was somewhere. 3 seconds later, the object is 8 to the right of where it was. So it's not the displacement of the velocity, but it is the displacement of the object itself, the position. How many knew it? 2 points, 3 for Mary. You need me to say that again. Okay, hands up again. Talk to each other, raise your hand. What's the other way to compute displacement? One way to compute displacement is to integrate velocity. But because displacement means how different is the position at time 0 compared to the position at time 3, what's the other way to write down a formula for computing displacement? Like I know this equals 8, but I also know something else equals 8. Hands up, come on. You know this. It's from the last unit. What's the other way? Sophie?
The position at time 3 minus the position at time 0.
Okay, raise your hand if your hand was already raised and you were prepared to say that. 2 points, 3 for Sophie. You want me to talk about it more. It's just review, but if you need me to talk more, it's fine. Okay, look at the board. You got to see everyone's eyes up. Come on, everybody, Justin, look at it. Okay, the AP test is worth 108 points. Your ability to understand, memorize, and use the fundamental theorem will gain you 30 points. Okay? So there's nothing more important that we study all year long than this. The idea that if I can find the displacement by integrating velocity, but I can also find the displacement by just comparing the position. Okay? So the fundamental theorem says this is equal to this. Talk to each other and raise your hand. What's another symbol that means exactly the same thing as V? Hands up. What's the other symbol we've used it before that means exactly the same thing as velocity? Like what is the velocity? Like what's the mean? There we go. What's the meaning of the velocity, Howard?
X prime.
So I can write this like this. Okay, I don't want to overemphasize, like, oh, this is really important, and then the next day, this is really important. But there is nothing more important than what I'm discussing now, the fundamental theorem. Who knew this? 2 points. Okay, 3 for Howard. Okay, I'm describing how the fundamental theorem applies to velocity and position. But the fundamental theorem applies to any function, and that function's derivative. So we can rewrite this like this. Okay? The theorem applies to any function. Got it? Okay, one person's going to raise their hand, earn 3 tickets by telling me how is f related to f prime, like in words. Like we say f prime is the blank of f, or we say f is the blank of f prime. Abby? So f prime is the derivative of f, therefore f is the antiderivative of f prime. Pretty good? Okay, that statement, f is the antiderivative of f prime, suggests a way to compute an integral's value without using your calculator. Think of this as, I forgot the dx, sorry. Think of this in right here, what I'm about to circle. Think of this as f prime. It says right here, you can find the value of the integral of f prime by figuring out what the f formula is, and then plugging into that f formula 3 and 0, and subtracting. So we can find this integral's value without a calculator in some cases, if we can find the formula for f. But as Abby just said, f is just the antiderivative of this formula. So on your flashcard, you need to remember, you now have a new way to find the value of an integral. Using the fundamental theorem and antiderivatives, we can find the value of an integral. So we're going to do that right now. So we want to find the antiderivative of this formula. Once we find that antiderivative, we can plug into that f, 3 and 0, and find the value of the integral. Question? You need to go through that again.
Question.
Please.
It won't be a perfect like integral, right? Because we don't know what c is when we do the anti.
Oh, hold on. Hold on. Ticket bequeathing ceremony. This is what Carson said. He's concerned about the fact that we always have this c when we find the antiderivative. Watch what happens. We're going to find the value. F's going to be something, right? So I'm just going to make something up to make talking easier. Let's pretend f turns out to be just x squared. So we got to take x squared, plug in the. Okay, wait a minute. It's right like this. So we figure out that f ends up being x squared plus a constant. Okay? Please. Oh, thank you. The terminology is messing you up. I totally agree. So this is what they're calling f. I want you to just pretend, forget that just momentarily, to make it fit with this for a second. So I'm going to think of this as f prime, which means if I find f, I can find the value of this integral. Using their symbols, this would be f, and you would need to find, in fact, they'll write it like this. Here's another way to write the fundamental theorem. Everybody, come on, look at the blue. Listen to Sarah's question. Look at the blue. Don't talk. Focus. 30 points out of 108. Look here. The relationship between f prime and f is exactly the same as the relationship between f and capital F. So I need someone to say what Abby said in words. Looking for a volunteer. How are these two related? It's the same relationship.
F is, capital F is the antiderivative of f.
Perfect. Just like little f is the antiderivative of f prime. If you write the fundamental theorem using these symbols, you are saying that capital F is the antiderivative of little f. So in this problem, it might make more sense to use these symbols since they've already given us an f. And so I would say, one second, Sydney, that for my made-up example, capital F over here is going to be x squared plus c. That's what Carson was talking about. Good question. Sydney?
Wait, so on the blue, the left is the rate of the right side of the equation?
Yes. Yes. Hey, look up. Look. It's the silly rhyme I use all the time. If you integrate the rate, you find the change in the amount. Yep. Everybody good? Lots of tickets today because the focus is really good. Please, Luke.
What is c?
You were gone last time, so you have to check the video to get more detail. But c is like 5, -2, just some constant. We don't know. So 2 points. Okay, back to Carson's question. If this is capital F, to solve the value of this integral, I want everyone to raise their hand this time. I want to make sure you're following. And we're just pretending to make the talking a little bit easier, to skip all the hard steps. If this is capital F, how do I use this to find the value of this integral? Hands up. Don't overthink it. It's just right in front of you. I just want you to say it versus me saying it. According to the fundamental theorem, if I'm trying to find the value of this integral, and I have found this to be capital F, how do I compute the value of that integral? Don't overthink it. Talk and raise your hands. Come on, we gotta get more hands. Okay, hands, come on, show me. Got a few more hands would be good. Kennedy, what do you say?
Oh, that you can plug in 3 for x and 0 for x, and then plug those into the equation.
Perfect. So here's how you write that. You say the integral from 0 to 3 of small f. I'm using t, but x would be the same, is equal to what Kennedy said. I want the capital F formula, and the bar means you're going to plug into this 0 and 3 and subtract it. Okay? Nick Wilson in A1 said he'd like the bar named after him since it's not named after anyone. So if you find me calling this the Wilson, that's because of Nick. So, okay. 1 year it was Frank, so I don't know. Questions? So then this becomes this. F of 3 subtract f of 0. We're almost to your question, Carson. Hold on. Like that? So how many knew this is what we needed to do? Show me. Point. Okay, 2 for Kennedy. Question? So now if I use this little kind of simple example, here's what happens. You plug in the 3 plus the constant minus. Okay, you've got to be careful. When you subtract, you need a big parenthesis because there are multiple terms to follow. Got to plug in the 0 and then the plus c. Look at this equation. Tell me if you can tell me what happens to the c. Hands up. Come on. Look at the equation. Look at it. Come on. What's going to happen to the c? Hands up. Garrett.
The c minus c is going to be 0.
Perfect. Thank you for not swearing. Good work. I heard some people like inappropriate language. The negative distributes. C minus c is 0. So the c actually doesn't matter. Like your thought was perfect, but it turns out it doesn't matter. So this is how we're going to solve the integral, and c doesn't matter. Question? How many knew that was going to happen? 0.2 for Garrett. Okay. Question? Awesome. Okay, let's keep going. Waiting for the board to copy. There we go. So here we are. We got 1/2 the integral from 0 to 2 of x squared square root x cubed plus 1 dx. I rewrite that as 1/2 integral from 0 to 2 of x squared x cubed plus 1 to the 1/2 power. Okay, so the big idea is you temporarily just think of this as being f prime. It isn't because it's out, but temporarily. We need to find the antiderivative. I look at my pink sheet. There's no formula on the pink sheet for which this fits. Okay? One thing I often would try to do is distribute like this, but I can't because of the 1/2 power. So my best option is Usubstitution. Oh yeah. Oh, you heard about those?
Yeah, they're on the video.
Oh, they are in the video. Yeah, like I butchered that one. I thought I had it right. Like it's like saucer, and everybody's like busts out laughing. What did I get wrong? They're like, you've been saying it that way your whole life. I'm like, I don't know. Possibly. Maybe my children say it that way too. My mother-in-law always says Washington. So. You guys, like, let's go to Washington. What? You need to wash your clothes? Where's the R? I don't know. Okay. Wow. I was actually watching a show last night on Netflix, and they said sorcery. How do you say it?
Sorcery.
Sorcery. And I'm like, oh yeah, sorcery, not sorcery. Feels like Olive Garden sorcery. Okay. Hey, look. Oh boy. Okay, Usubstitution. Sorcery. Two functions multiplying. Identify that both of those functions are of the form something to a number. In the first case, the something is x. That's never going to help with Usubstitution. In the second case, the something is x cubed plus 1. Remember, always two columns. Okay? Just write how I write, so if I need to help you, I can help. It's just a nightmare to try and follow your work if you don't do it this way. So U is going to equal x cubed plus 1. Question? Okay, it's always better that you think with me, not just listen. So raise your hand and tell me, what is the derivative of x cubed plus 1? Hands up, come on. What's the derivative of x cubed plus 1, Michaela?
3x squared.
3x squared. So I look over here, and here's how this is what I think. Look over here. I say, my choice of something came from this function. The derivative of my choice is this function. Because I don't care that this is a 1, and over here it's going to be a 3. It doesn't matter. So I know that I've made the right pick. I know that Usubstitution will work. Please.
Why aren't you using the 1?
What's the derivative of 1?
Like in your original equation.
Now keep talking. I'm not sure what you mean. Keep going.
So when you did the square root, you had to change it to 1/2. So why aren't you using that as a use of?
The 1/2? Oh, good question. 2 points. 2 for Michaela as well. Sorry. Remember the steps, Allie, are, there's 2 key words here. Function and the something. So you start by saying I've got 2 multiplying functions. Both of them are of the form something to a number. So now I'm going to think of the something, because like the movie, U is always something. I swear it will help you. U is always something special, okay? So I've got the 2 functions, but the something is just this. So I always pick the something as U. Okay? Okay, 2 points. There we go. I took the derivative of my something. Now here's where the words switch again. The derivative of my something came from this function. The derivative of my something must be the other function. Got it? Okay. So everything's going to work, so I just keep going. I remember over here that I'm going to multiply the dx across. I'm going to move the 3, so I get du divided by 3. It's equal to x squared dx. Dividing by 3 is the same as multiplying by 1/3. Question? Okay, we have one more element of sorcery here. Okay. On the buff sheet, when you're finding an antiderivative, you make your Usubstitutions. You finally use the pink sheet to find the antiderivative, and then you go back to x. If you're using Usubstitution to find the value of an integral, you move to U and you don't go back. Okay? It's not illegal to go back, but if you go back, you're going to miss some questions on the AP test where they require that you not go back. So don't go back. Change to U, stay with U. The process is identical, so you don't have to really think much else. Just change to U, stay with U. So right here, this 0 is x equals 0. Because remember how integration works. You plug in 0 here, you multiply by a tiny value of change in x, Then you plug in 0.1, 0.2, 0.3. So these are x values. We need to change them to u values. But we have an equation right here that tells us how. So just use that. Write on your paper. U equals, the upper x is 2 cubed plus 1. So that's 8 plus 1, which is 9. The lower limit is 0. That will go pretty quick. 0 cubed plus 1 will be 1. So notice, this side of the page, this column, is where we solve the problem. This side is where we figure out what are all the different things that are going to be substitutes. So we start substituting everything. We're going to put a 9 in place of the 2. We're going to put a 1 in place of the 0. We're going to put a x cubed plus 1, sorry, a u in place of the x cubed plus 1. We're going to put 1/3 du in place of the x squared dx. So we are substituting 4 different things. That's why it's called Usubstitution. So, question? Plug it all in. 1/2. 1, 9. I write this first, it's easier. U to the 1/2. Then I have x squared dx. But x squared dx is just 1/3 du, so this becomes 1/2 u to the 1/2, 1/3 du. These are multiplying factors, so the 1/3 being a constant can come out, and you get this. Question?
So 54 is 27. Why do I care about 27? That's so big.
Awesome. That's the process. Now, from here, it's pretty much like what we did. Well, actually, it's all like what we did last time. I'm going to copy this to a new page so I can get some more space. But let's see. Copy.
Oh, what's Mr. 3? They're all like through now.
What? I don't know. There we go. I'm erasing this. If you need me to go back, I have a copy. So. Anybody need me to go back? Good. Okay, so. So this becomes 1/6. The antiderivative of that's going to be u to the 1/2 plus 1 divided by 1/2 plus 1. Okay? Question for the whole room. So talk together and raise your hand. We have a function right here. We have a function right here. The constant out front I'm ignoring. Raise your hand. You must be able to do this. 30 points out of 108. How are these two functions related? Show me your hand. How are these two functions related? Can you?
Is u to the 1/2 the derivative of
That other mess. Yeah, good word. This is pointing helps. This is the derivative of this. How many knew it? 2 points, 3 for Ken. Therefore, the fundamental theorem says, if I'm integrating, like Sydney says, the rate, I just need to find the formula for the amount, and then plug in the two values. So we Wilson it. Draw the Wilson. Apparently not a very popular name. We must come up with something new. Okay. I'll have to inform Nick. His name just didn't work. So. Okay, please.
Do you know to the plus C before the bar?
Oh, remember previously, and if you forgot, we'll go back and show you. But remember how we discussed that the plus C is going to subtract out anyway?
So you just...
So you don't ever have to write it.
Okay.
Good question. 2 points. Yeah, that's understood, Mary, when you're taking the test. That they just go with the assumption that everybody remembers it gets subtracted anyway, so no one ever has to write it. So, please.
Can you explain why the difference?
So remember, the fundamental theorem says if I'm integrating from 1 to 9, small f, I can find this integral's value by finding the antiderivative, which we call capital F, and then plugging into that antiderivative 9 and 1. Does that feel good? So that's the fundamental theorem. Okay, the bar, the Wilson, whatever you want to call it, is just a way, it's just notation that means the same thing. So writing this means this. That's all. Is that okay? 2 points. Anyone else? So keep going. So 1/6. This is 3 halves. Dividing by 3 halves is the same thing as multiplying by 2/3. So 2/3. This would be u to the 3 halves power. Wilson 1 to 9. So questions? Please, Justin.
How did we get to 2/3?
So are you okay that 1/2 plus 1 is 3 halves? I have, this is just like one big fraction. So I got 1/6 times this, right? Let's write it over here. So you've got 1/6. That would be a 9. That is saucery. I can't believe that spread so fast. So, wow. 1/6. This is u to the 3 halves divided by 3 halves. You okay with that? So this divided by 3 halves is exactly the same thing as this multiplied by the reciprocal, 2/3. 1/6 u to the 3 halves multiplied by 2/3. But now you just have 3 factors being multiplied. Order doesn't matter, so I just put it out. Okay. Question, 2 points. Anyone else? Cool. So plug and chug. Those divide 1/9. A multiplying constant is going to show up in both places, so I just factored out. So I have u to the 3 halves, so that's 9 to the 3 halves, minus 1 to the 3 halves. Question? Okay, on the AP test, you can stop right there if it's an FRQ. Multiple choice, we have to keep going. Okay, fractional exponent. Mr. Recti teaches this all the time. He says the power is on high and the roots are below. Except he yells really loud. Power is on high, the roots are below. You can do whichever one you'd like to first. Just pick whichever's easiest. Would you like to take 9 to the 3rd power, or would you prefer to find the square root of 9? You guys are all very smart. Square root of 9. Okay, that was not meant to be sarcastic. You all are very smart. That was not meant to be sarcastic. I do not like sarcasm. I feel like it is cruel. Okay. Got it? So the only time I use sarcasm is when I tell you I'm going to. And it kind of spoils the whole thing. That's good. So the square root of 9 is, say it? 3. Now you must take 3 to the 3rd power. More commitment would be good. Confident? 27, yes. Coach, thank you. 2 points. Please.
I'm confused how we got the 27.
I'll talk you through it again. Okay. Mr. Rucky says, power is on high. It's kind of a common phrase. The roots are below. So you have to take the 9 and do both, power and root. You get to choose which do you want to do first. So that means you have to tell me what's 9 to the 3rd power. If your answer is I don't know, it's okay. Just say I don't know. Good. So go the other way. Do the root first. So the 2 on the bottom means square root. So what's the square root of 9? There we go. Now you do the power. What's 3 to the 3rd? That works. Anybody else? Anybody else? Please.
Wait, so you do the square root of 9 divided to 2 at the bottom?
Say it again.
So you do square root of 9 divided to 2 at the bottom? And then you do
That makes sense. Yeah, you just have to do both. And it doesn't matter the order. If you were 3 on the bottom, it would be the cube root. Well, they won't give you that because you don't know it. It's a problem designed by people, right? So they make the numbers all work out. Yeah. Yep. Hey, look up. Question? Cool. Let's do another one.